Welcome to our overview on how nanotechnology is fundamentally changing industrial automation. Get ready to explore the microscopic world with macroscopic impact. Nanotechnology is quickly becoming the new frontier in manufacturing, driving enhanced capabilities and pushing the boundaries of what is possible in industrial automation. This powerful technology is revolutionizing the industry by enabling advanced sensors, stronger materials, nanorobotics, and sophisticated nanoelectronics. We'll dive into the key applications of nanotechnology in industrial settings and the numerous benefits they bring to manufacturing. Let's begin by examining some of the crucial ways nanotechnology is being applied in industrial automation. Nanosensors are essential for smart manufacturing and the Internet of Things, providing highly sensitive, real-time data for precise monitoring, quality control, and predictive maintenance. Nanorobotics, nanoscale robotic systems, are being developed to perform incredibly precise tasks, like assembling intricate semiconductor components and performing internal system inspections or repairs. Nanomaterials like graphene and carbon nanotubes create composites that are much stronger, lighter, and more durable, extending the lifespan of machinery and products across various industries. Miniaturization of electronic components through nanotechnology leads to faster, more powerful, and energy-efficient control systems, which are the backbone of modern industrial automation. 3D nanoprinting enables the fabrication of complex, customized nanoscale structures with unprecedented precision, which is key for specialized components in medical and industrial fields. Now, let's explore the substantial advantages gained from integrating nanotechnology into industrial automation. Nanomanufacturing allows for production with nanometer accuracy, drastically minimizing defects and boosting overall product quality and efficiency. The use of nanomaterials results in final products with superior properties, such as lighter cars with better fuel efficiency and longer-lasting electronics. Nanotechnology supports greener manufacturing through more efficient energy usage, minimizing material waste, and facilitating pollution reduction with advanced catalysts and filters. With nanosensors detecting potential structural weaknesses early, nanotechnology significantly increases safety and reliability in industrial systems, helping to prevent catastrophic failures. While the potential is vast, we must acknowledge the hurdles that come with widespread adoption. The primary challenges include the high cost of research and development, difficulties in scaling production from the lab to industrial levels, and ensuring uniform dispersion of nanomaterials. Continued research is crucial to address the environmental and health impacts of nanoparticles and to develop clear safety guidelines and regulations for this technology. Nanotechnology is poised to unlock truly autonomous and adaptive manufacturing systems, dramatically shaping the future of industrial automation for years to come.